Oh, I have part 2.
All right, I know we have questions because a lot of people said they didn't know how to do 71.
Yeah, I didn't get that one.
All right, let's do it. Oh yeah, Monaco and Nihinu are absent.
Mike is not here today. We have a
Are
group project to work on.
you meeting at lunch now?
Yeah.
Can we do 57?
Okay, let's do 71 first.
Oh.
A hall, so basically you have an ellipse. This is a whispering gallery thing. Okay, let's put the origin, the center at the origin, because that always makes it easier. The hall is 100 feet in length, so wouldn't this be 50 comma 0? Right? Negative 50 comma 0, because the hallway is 100 feet long. What number are we doing for 71? The foci are located 25 feet from the center, so if you go 25 feet this way and 25 feet that way, these are the foci. Negative 25 comma 0 and 25 comma 0. So the question is asking, how high will the ceiling be over here? They want to know this distance right here. Well, if you could write the equation of this ellipse, this problem is pretty darn easy. Well, since the center is at the origin and the major axis is horizontal, then isn't this the equation of the ellipse, like this? And what are we trying to find? We're trying to find this distance. What is this distance right here? Isn't that B? Because isn't A tell you how much to go left and right, and C is how much to go left and right for the foci, right? So they're telling you what A and C are, you just have to figure out B, but isn't that kind of easy? Because what's the equation for the ellipse that relates A, B, and C? C squared equals A squared minus B squared. So we already know what A is, right? A is from here to here, A is 50, so A is 50, so you put 50 squared there. And C is the distance from the center to the focus, which is 25. Can you figure out what B is from that equation? Yeah! So B squared is equal to 50 squared minus 25 squared. So this is what I would do. Now, the other class, they wanted to multiply it out and go, okay, 2,500 minus 6. You know what? Why don't we just do it their way, because that's probably what you're going to do. And if you subtract that, you get? Oh boy. Okay, 1875. So therefore, B is the square root of 1875, but then you gotta simplify that. Well, how do you simplify that? Well, 1875, I know 25 can go into that, right? You know how you can tell 25 goes into a number? Just look at the last 2 digits. Can 25 go into 75?
Yes, sir.
Okay, so 25 goes into 1875 how many times? I'll tell you, 75. But then 75 is 25 times 3. So this is the same thing as the square root of 25 times 25 times 3. But 25 comes out as this 25 comes out as a 5, so this is just 25 root 3. Kadoon! That's how tall this should be right there.
Wait, will B always be the height of it?
Yeah, because remember in an ellipse, A is how far from the center to the vertex, right?
25 times what?
Radical 3. And then B is how far you go from here to the end of the minor axis,
So
right?
even if you know that ellipse is like this, what if the ellipse is like more vertical?
Oh,
Would it be the same thing?
what do you mean more vertical? You mean longer than 50?
No,
But it
no.
can't be because the focus always lies on the major axis.
Okay, but what if the major axis was vertical?
But it's not.
So like, what if it was? Like, you know, there's like problems where like.
Oh, but in this one it's not, right? Because the whole.
Yeah, but if it was, would B still tell you the height of the?
Well, if the major axis is this way, then this is A. See, look, if the ellipse is this way, then this is A, and that's B and B.
But if it's horizontal, then it's opposite.
No, it's just the major axis is the one with the A, The minor axis
Okay.
is the one with the B, right? Yeah, so it doesn't matter which way.
Park, I found it. Do you wanna look at it real quick?
Okay.
I did do 69 or 71, I didn't get it. I really didn't get 71.
Well, at least draw a picture.
Sorry. I'll draw a picture now.
Well, of course I drew a picture there. Okay, somebody said another number, 50 something?
57.
57. Write the equation for the ellipse. So the best thing to do for these problems, you know, I just wrote the test, which is next week, Thursday.
Oh, we have a test next week.
We have a quiz tomorrow.
Yeah, the quiz is tomorrow. What? Yes, there's a practice quiz online. I'm surprised you guys didn't even do it yet.
I did it.
Vertices are at 4, 3, and I'm trying to concentrate here, 4, 9, and one focus is at the point 4, 8. Write the equation of this ellipse. Okay, so the best thing to do is draw a picture. So 4, 3, 1, 2, 3, 4, 1, 2, 3, and then 4, 9. 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9. So these are the two vertices, like that. So if these are the two vertices of the ellipse, then that means the major axis is that way, right? Because the vertices connects the major
So that's
axis.
A, that line that you.
Well, this is 2A actually, right?
Yeah.
So the center will be located, see, the key to writing an equation of any graph, circle, parabola, ellipse, hyperbola, which we're gonna learn today, you gotta find the center, except parabola doesn't have a center, it has a vertex, but you gotta find the key point, which is the center. So if these are the two vertices, 4, 3 and 4, 9, where would the center be? Wouldn't it be halfway in between? Yeah, so just use the midpoint formula.
4.6.
We remember the worksheet we did at the very beginning?
Yeah.
John, you look at me, you don't chew gum.
I'm not chewing gum.
I saw it. You went like this, and then you realized, oh, I better stop.
Not even far.
Yes.
Not even.
Okay, you guys remember the midpoint formula?
Yes. X1 plus X2 over
Yeah,
2.
you add the, you basically take the average of the x coordinates, you take the average of the y coordinates, it's gonna give you the midpoint. So what's the average of 4 and 4? What's 4 plus 4 over 2?
4.
What's 9 plus 3 over 2?
6.
6. Now once you have the center, you can write almost the whole equation already. Here, Jack, why don't we do that? Once we got the center, let's say you're on the test. This is the only thing you can do, the only thing you can do is find the center. At least you can, don't leave it blank, earn some points here. Now, since the ellipse is an up and down ellipse, what comes first, the x's or the y's? The y's. So it's going to be y minus 6 squared over a squared plus x minus 4 squared over b squared. That's equal to 1. And then all you have to do is figure out a and b, right? And then the problem's done. Well, a is the distance from the center to the vertex. What is that distance right there? How far is it from 6 to 9? 3. So we know a is 3 already, so what is that then? What is a squared? 9. So all you have to do is figure out b squared. But Mr. Park, they don't tell us what b is. Yeah, you gotta figure it out. So they tell you that one focus is at 4, 8. It's up here. One focus is at 4, 8. What is the distance from the center to the focus? Isn't that what C is? So how far is it from 4, 6 to 4, 8? Basically, how far is it from 6 to 8, they're asking?
2.
2. Now, if you know what A and C are, how do you figure out B? What's the equation that you have to know for units? C squared equals A squared minus B squared. So for tomorrow's quiz, this is key. You gotta know this. Just like the parabola, you gotta know what 4p is, right? For the parabola, 4p. Oh gosh. Someone's going, what's 4p? Okay, so C squared is 4, A squared is 9. Can I figure out what B squared is? Yes, B squared is equal to 9 minus 4, which is 5. So that's 5. Boom! That's your answer. I'm telling you guys, this is the key to solving ellipse problems right there. C squared equals, well, besides knowing what A, B, and C mean, that's the equation that you gotta know. All right, any other questions? Everybody can complete the square, because tomorrow, if you looked at the practice quiz, you're gonna have to complete the square.
Did you put the answers on the-
Yeah.
Yes, I did put the answers to,
Okay.
like I normally do. Spoiled you. Okay, no, everybody can complete the square, you sure?
Yeah, divide the second by 2 and then.
You know what,
square.
I'm gonna do 51. Let's go through completing the square, because the other class, it's like, what's going on? Because tomorrow, you're gonna have to complete the square for the parabola and the ellipse, and if you cannot complete the square, you're in for it. Okay, here's 51.
Spark went the other class.
So what is that supposed to mean?
He's better than them.
Why did you tell them that on video?
Stand right in front.
Sit down, Chan. Sit down.
What's wrong with
Okay, now for those of you who forgot how to complete the square, on the test, which is next week, you're gonna have to complete the square like 3 times. You gotta do it for the circle, a parabola, the ellipse, maybe even 4 times for the hyperbola. Okay, so this is what you do. Here are the x terms. You put all the x terms together. So you got the x family. Here is the y family. Put all the y terms together. Throw a number on the other side. Now look at the 2 x terms. What can be factored out? Well, whatever number is in front of the x squared, that's what you factor out. So I factor out a 9. Now you're probably going to be lucky where I'm going to make it come out nice. But then when you go to pre-calculus like that, it's not always nice. So. Anyway, so what is that? X squared minus, if I factor out a 9, 2x, and then leave a space to complete the square. And then what about these 2 terms? What can I factor out? 4, y squared plus 4y, then you leave a space. Okay, now, what do I have to add right there to make a perfect square?
1.
Very good. But what did I actually add?
9.
9 times 1. So you have to add 9 to both sides. Now what about here? What do I have to add in the parentheses to make a perfect square?
4.
4. Good. But I actually added 4 times 4, which is 16, so make sure you add it to both sides. And so this is what you got. 9 x minus 1 squared plus 4 y plus 2 squared equals 36. Now, to put this into standard form, you need this side to be 1. So how do I get that side to be 1? Subtract 35 from both sides. No, you divide by 36. So if I divide this by 36, see how it comes out nice? 9 goes into 36
4 times.
See, it comes out 9. And then if you divide this one by 36, here, let's go like this then. Over 36, over 36, over 36. 4 goes into 36 9 times. See the book, see, when I make problems, I make the column nice. I mean, it's okay to do this. So, notice that the bigger number is under the y. So this is the a squared, this is the b squared. Remember, a squared is always the bigger number.
Oh.
I knew that, right? So this ellipse is an up and down ellipse. It's like this. Where's the center? 1, negative 2. Okay? So what if a squared is 9, what is a? Let's figure out a, b, and c right now. Go. 3. B is, if b squared is 4, b is 2. And how do you figure out c?
C squared.
C squared equals a squared minus b squared. Why don't we just do this whole problem? So that comes out to 9 minus 4, which is 5. So that means c is the square root of 5. So the important parts of the ellipse, this is the major axis. These are the 2 vertices right here. So to get to the vertices, you just simply go a up and a down. So if I go 3 up, you're going to be at, if this is the center, and I go 3 up, where are you going to be? 1 comma
4. Oh, just kidding. 1.
1. And then go 3 down, 1 comma negative 5. Okay, this is the minor axis. Let's put some more here. What are the coordinates of the endpoints of the minor axis? Now, well, you just go b left and b right, right? So 2 left and 2 right. So from here, if I go 2 to the left, where are you going to be? Negative 1, negative 2. And if I go 2 to the right, you can be 3, negative 2. See how easy that is?
So B is always the minor axis?
Yeah, b is always the minor axis, a is always the major axis. And then c is the distance from the center to the focus. So radical 5, so from the center, you go radical 5 up and radical 5 down. That's how you get to these foci here. So if I go radical 5 up, you're going to be at 1 comma negative 2 plus radical 5. See how ugly that is? I mean, it's not that ugly. And then if I go radical 5 down, you're going to be at 1 comma negative 2 minus radical 5. Well, if you do all your work correct tomorrow, there'll be whole numbers. Because otherwise you got to go, okay, what is radical 5? It's 2 point something. It's not that bad. But anyway, so do the practice quiz. Yeah, if you guys haven't learned by now, that's the key right there. I keep telling you guys, even if you screw up on the homework, right? You got the practice quiz and the practice test, man.
Like I literally went out until like an hour before now.
Okay, today we start the hyperbola, and again, look at the assignment sheet. We're gonna spend 2 nights on the hyperbola right here. Ah!
But it's like so cute. It's like oh, it's so
Right there.
no.
So I'm gonna teach you everything you need to know today. So you just 2 nights to do it. So same thing. I'm gonna check both homeworks, John, on Monday.
What was that? What was that?
Check your both homework, the live tour.
So I'm not gonna check tonight's one for your information, but I'm gonna check both of them on Monday.
I'm gonna have like 10 assignments for you, Mr. Park, on Monday.
No, because we're gonna have some questions on the hyperbola homework, I'm sure.
Like it's okay if we don't do it though.
Until
Well, I would rather have you do it, but
I know,
if
but
you
like,
wanna
you
take a
don't
night
have
off
to
and do them, then you're gonna have double homework.
Stress.
Yeah, but Mr. Park, your homework's so short, I can do them all in 20
No, it's
minutes.
not. It takes a while.
Yeah, it takes me like at least an hour and a half.
Boo-hoo, you didn't even do it, fool.
But sometimes it does.
Okay, let's review the ellipse. Now, do you guys remember what the definition of the ellipse was? I bet some of you forgot.
All the
Mm.
points
Is that
when you
stricter
move.
than-
There are 2
like-
fixed points. These are called the foci. Remember the string thing I showed you?
Yeah.
Okay, the definition of the ellipse, it's the set of points in a plane such that, so if this is a point on the ellipse, then this distance plus that distance always has to be constant, it doesn't change. So PF1 plus PF2 is always a constant. You guys, a constant means it doesn't change, like the length of the string didn't change, right? And then if you go around, you get the ellipse, so it's kind of ugly, yeah? And then this was the major axis and that was the minor axis, like that, right? Oh boy. Now today we're going to learn the hyperbola. Now the hyperbola definition is almost the same as the ellipse. Instead of the sum of these 2 distances being constant, it's the difference of the 2 distances is constant. And then, so if you subtract them, I guess you gotta put absolute value because you cannot have negative. But if you take the bigger distance and minus the smaller one, and it remains constant, doesn't change, what you get is a hyperbola, which looks like that.
Wait, the difference between the PF1 and
Yeah, so
PF2?
this distance minus that distance is always constant, it doesn't change. That's the definition of the hyperbola. And since the definitions of the 2 conic sections are the same, almost the same, then you can expect the equations to be the same. Now, if you look in your book actually derives the equations. Did you guys even look at that?
What is wrong?
Yeah, because these equations don't just come out of, they just appear out like magic. You have to derive them. Now, normally in the honors course we derive it, but in regular we don't derive it. But if you want to see it in your book, no, that's okay. Okay, so if you have a hyperbola, see how the center is the same place? If you have a hyperbola that opens left and right, these are the equations of the hyperbola. And look, it looks kind of familiar. Like that. See, if it was a plus sign, that would be an ellipse, a left-right ellipse, right? But if you put a minus in between, what you get is a left-right hyperbola. Now, if the hyperbola is going to open up and down, in other words, the 2 foci are this way, then the equation looks like this. And again, see, if it was a plus sign, it would be an ellipse. But it's not. So to make it easy, if there's a plus sign in between, it's an ellipse. If it's a minus sign in between, it's a hyperbola. So tonight's homework will be all minus signs there.
So it's kind of like the same thing. Right?
Yeah, it is. It's kind of the same, but you're going to find that hyperbola is much more complicated. So here, I'll box this. These are the equations that you got to know. Now remember, in an ellipse, C was the distance from the center to the focus, right? Same thing for the hyperbola, except in the ellipse, it was C squared equals A squared minus B squared, right? But for the hyperbola, C squared equals A squared plus B squared. All right, so why don't we go through a whole problem, and I'm just going to show you all the important parts of a hyperbola. Okay, can I erase this now? Because I can't go to that side because we're filming, so we've got to stay on this side of the board. Okay, I'm going to erase. Anyway, these are all in your book too. So here we go. Let me give you an equation of a hyperbola. X minus 3 squared over 9 minus y minus 1 squared over 16 is equal to 1. How do I know this is a hyperbola? Minus sign. X1 came first, so this one's going to open left and right like that. It's going to look like that. Okay, so what you need to do on tonight's homework, you got to graph it and then label all the important parts. Okay, so where's the center? The key is you got to know where the center is. Where is the center of this hyperbola? 3, 1. So you go 3, 1. Here is the center. 3, 1. Okay, now let's identify. Now in an ellipse, A squared is always the bigger denominator, right? B squared is the smaller one, but in a hyperbola it doesn't work like that. A squared is always the one that goes with the first term. B squared is always the one that goes with the second or the negative term. Okay? You guys got that down?
Can you repeat that?
Yeah, can you say
A
it again?
squared is the one under the first term, the positive term. B squared is the one under the negative term. So sometimes B is going to be bigger than A. But in an ellipse, A is always bigger than B, right? But not necessarily in a hyperbola. Well, if A squared is 9, what does that make A then? 3. And if B squared is 16, what does that make B? Come on, man. 4. Now let's figure out C. Now remember, in a hyperbola, C squared is equal to what? A squared plus B squared. You got to keep those two straight. So what do we got? 9 plus 16, which is 25, which means C is 5. See how I make my numbers come out good? Okay, now this is how you graph a hyperbola, okay? So you start from the center. Okay, the number under the x, which is in this case the a, the square root of this number tells you how much to go left and right. Same thing like the ellipse. So I go 3 to the left and 3 to the right. Okay, you look at the number underneath the y's. The square root of that number tells you how much to go up and down from the center. So 4. So I'm going to go 4 up. 1, 2, 3, 4. And 1, 2, 3, 4. Now, if this was a plus sign, wouldn't you just draw it like this already? Just make the ellipse right there? But this is not an ellipse. This is a minus sign. This is a hyperbola. So this is what you got to do. So using these 4 points, what you do is you make a rectangular box like that. Like I told you, if this was an ellipse, you just go boom, and then you're done. Hyperbola, much more complicated. So you make a rectangular box, and then you draw in the extended diagonals like this. You guys know what diagonals are, right? Go and then down to there. Okay, there you go. These are the asymptotes of the hyperbola. Okay, now, if the x comes first, if the x1 is positive and the y1 is negative, then the hyperbola opens left and right like this. If the y was first and the x was second, then it would go up and down. So since the x is first, see, you see these 2 points here? these are the vertices, so the hyperbola looks like this. And you guys know how asymptotes work, right? They get closer and closer and they don't touch, right? Same thing over here. Wow, it gets closer and closer but doesn't touch. There you go. That's the graph of the hyperbola.
So there's less points to find.
No, there's going to be more. There's more stuff to figure. So if it was switched, if the y came first, and then it would just be up and down like this. But the x came first, so it's going to be left and right. Okay, so let's identify everything. These 2 points, just like the ellipse, these are called the vertices. Okay, call them V1 and V2. So how do I compute these vertices? Now, if this were an ellipse, this is called the major axis, right? That connects the 2 vertices in an ellipse. But we cannot call this the major axis anymore because look, this one is smaller than that one. So that's why we cannot use major and minor axis just like the ellipse. So the axis that connects the 2 vertices is called the, did anybody read the book? Of course not. It's called the transverse axis. That's the one that connects the 2 vertices. And the one here that doesn't connect anything, we call that a conjugate axis. Why do we have to have these strange names, Mr. Park? Because we can't call it major and minor anymore. Because major means big, minor means small. Cannot.
Is the transverse one the up and down?
No, the transverse one connects the 2 vertices. So if the hyperbola is left and right like that, then the transverse axis is horizontal. But if the hyperbola opens up and down, then that's the transverse axis. It connects the 2 vertices. That's what the transverse axis is. The conjugate axis is this, the one that doesn't connect anything. This. So we call these the endpoints of the conjugate axis. So on tonight's homework, you got to label these points. So the center was at 3, 1, right? What was this distance again? 3. So if I go 3 to the left, where are you going to be?
-3.
No, if you're at 3, 1, and I go 3, 0, 1. In fact, how about just look at your graph and kind of tell me there. If you're at 3, 1, and then I go 3 to the right, where are you going to be? 6, 1. And then how much did it have to go up and down? 4, right? So if you're at 3, 1, and I go 4 up, where are you going to be? 3, 5. And then if you're at 3, 1, and I go 4 down, you're going to be at 3, -3.
Wait, if that's called the conjugate, why don't you label it E?
For endpoint of the conjugate axis.
Can you just label it C?
No, because we use C for, okay, if you want to call it, you can call it whatever you want. I think the book calls it E, but who cares what the book is? You guys don't even look at it. Okay, now what about the foci? Now, when you have an ellipse, here's the major axis. The 2 foci are like that, yeah? But when you have a hyperbola, the 2 foci are over here. But it's the same thing. Here's the transverse axis. See how it lies? It would lie on the transverse axis, or the extended transverse axis. So the 2 foci are going to be over here, like that. So how do you find the foci? That's where C comes in. Just like the ellipse, you just go C left and C right. So if I'm at the point 3, 1, if I go 5 to the left, 1, 2, 3, 4, 5, here's the focus. What is that going to be? -2, 1. And then if I go 5 to the right, 1, 2, 3, 4, 5, here's the other focus. What is that going to be? You're at the point 3, 1, and you go 5 to the right. What is 3 plus 5? 8. Boom! Now you might think, oh, Mr. Park, it's a lot of work. We're not even finished yet.
Wait, before we continue,
Okay.
so C is
How many problems are on the other?
C is the distance from the center to the focus, just like the ellipse. Look, in the ellipse, wasn't C the distance from the center to the focus? Same thing with the hyperbola. The distance from the center to the focus is C. That's why, if the definitions are the same, you can expect a lot of the things to be the same.
So what else do we have to find then? Like, isn't
The
that-
asymptotes. So we go, no, I'm just going to skip that problem. How are you guys going to survive in trigonometry?
Not.
Right. not gonna
You
survive.
guys don't even know what trigonometry is. It's the study of triangles.
I hate triangles.
Dude, I don't
Well, you
know.
better love them if you're going to trig. Okay, anyway,
Basically, I'm
you have to write the equation of these asymptotes. They're just lines, people. Okay, some of you going, Mr. Park, it's hard. No, it's not. Look, can you see that these two asymptotes intersect at the center?
so they're per.
No, they're not perpendicular. Okay.
That's good.
Well, sometimes they are, but in this one they're not, okay? So you have to write the equations. Now, what do you need to write an equation of a line? You need a point, which is the center.
And the slope.
Right, so the asymptotes always intersect at the center because you're drawing the diagonals in, right? So that's easy, that you already have the center. All you gotta do is figure out the slope. Now, there's two ways to figure out the slope. One is to just memorize, okay? If the hyperbola opens left and right, the slope of the asymptotes are plus or minus b over a. But if the hyperbola is an up and down one, then the slope of the asymptotes are plus or minus a over b. How am I gonna keep that straight? So in this problem, since it opens left and right, it's gonna be plus or minus what?
4 over 3.
B over A, which is 4 over 3. And if you have a point and you know the slope, what's the fastest way to write the equation of the line? Point slope form. So just go like this. Y minus 1 equals plus or minus 4/3 x minus 3. Boom! Those are the asymptotes.
Wait.
Remember point slope form from Algebra 1?
No. Okay.
Okay, here, let's review. How come the other class didn't ask for a review of point slope form? Y minus y1 equals slope times x minus x1. So here's the point. 3, 1, look, 3, 1. Here's the slope, you just put it over there. Bam! Yeah, but Mr. Park, you know what? I don't think I can remember the b over a and the a over b. I'll go get that mixed up, I know already. Okay, so if you don't want to memorize, then you know what you do? You just look at the rectangular box that you drew. Look at this line. Isn't the slope going to be rise over run? Isn't that what slope is, rise over run? So when you made your rectangular box, wasn't this 3 and that was 4? Remember? We had to go 3 right, 3 left, 4 up, 4 down. So what's rise over run? Here, let me put the 4 on this side. What's rise over run?
How did you just tell us? That's easy.
Yeah, well, so this one is positive 4 over 3, and of course, then this one will be negative 4 over 3, right? Because it's coming downhill. The slope is negative when it's coming down. So which way do you like better? You want to just purely memorize it or just look at the box that you drew? I don't care which one you do. All I'm looking for is, do you have this answer for the asymptotes?
Why is that? Why minus what?
How can you guys forget point slope form? You know, if you ever get to calculus, which you guys probably gonna take it in college then, right?
Yeah.
Point slope is so super important, you know, super
No.
important.
I'm talking about one blocks.
You know, because the higher up in math you go, you don't wanna do this. This is for babies. So what do you guys think? I'm a baby? No, I mean, it's okay. Like on the SAT and the ACT, they kind of want you to do it like that. But when you get to calculus, you want to do point slope form. Plus, think about it. It's easier. Okay, don't think about it. All right. So I taught you everything you need to know about the hyperbola. Now you gotta put it into action. Oh, last thing. Why do we study hyperbola? Just so teachers have jobs. No! You didn't learn from the parabola and the ellipse? Oh my goodness, it's giving me a race. I'm going to tell you why we study hyperbolas. Now, do you guys even remember the parabola thing? Oh gosh.
The bridge.
Okay, if you have a parabolic dish,
Oh.
if you have the rays coming in, like that, the light or the radio waves, or
Yeah, that's this one.
it bounces off the parabolic dish and it all goes to the focus, so that's where you put your receiver, right? In fact, that's gonna be a problem. That's gonna be a problem on the test. It's gonna be on the practice test. Anyway, it was a homework problem. Nobody asked about it. What about the ellipse? How did the ellipse work? If these are the two foci, if you have a light wave, a light laser emanating from one or sound, whatever, it hits the ellipse and where does it go? To the other focus. Remember I told you guys about whispering chamber?
Yes.
Kidney stone?
Yeah.
So what about the hyperbola, Mr. Park? Is there something with the hyperbola? Yeah, here's the two foci. If you have a laser and you aim it at one focus, let's say aim it over there, it's going to hit the hyperbola. You know where it's going to go? It's going to bounce off and go to the other focus. Now, how can you use this in real life? Telescope. You guys know what a telescope is? Because other class I did. You sure?
Where you zoom in on the planet.
How many of you went to elementary school at Iolani? Didn't you guys have space night on the baseball
Yeah,
field?
that was fun in the
Yeah, and they set up those Cassegrain telescopes like this.
Yeah.
Okay, let me tell you how a telescope works, okay? So you got the light from the heavens coming in, right? Okay, so at the very bottom, you have a gigantic parabolic mirror. It's got to be a parabola. And the ones that they have, like they're about this big, yeah? So it's a big mirror, okay? So all the lights coming in from the heavens, it's going to hit this parabolic mirror, and where is it going to all go? To the focus. But what's the problem with that? How are you going to see that? You put your head inside. You put your head inside the telescope like this.
Yeah.
What's the problem with putting your head inside the telescope? It's going to block all the light coming in. You're not going to see anything. So what we want to do is we want to reflect the image from here to the eyepiece. Now, where do you want to put the eyepiece? Over here? Okay, let's say it's got to be outside the telescope. Okay, so now you have a big parabolic mirror, right? It focuses everything over there. So, but we want to transform everything to the eyepiece here. So what you get is a hyperbolic mirror, a tiny one, a tiny hyperbolic mirror. Now remember, how does the hyperbola work? If all this light is going toward that focus, it's going to hit this hyperbolic mirror, and where is it going to go?
Focus.
To the other focus. So you just make sure that these are the two foci of the hyperbola. And then now you can see the image. So that's why we study conic sections, because they have real life applications. And remember Donald Duck in Mathemagic Lab? You have a sphere. What happens when you cut a sphere like that?
Wait, you repeat.
You get a magnifying glass. You get a lens. You have you guys know what a sphere is?
Yeah, so like a ball.
Remember Donald Duck in Mathemagic Lab? You cut it like that. Then you get a lens. Magnifying glass. Okay, we are done. Class ends at 10:10, so you guys have 12 minutes remaining. Here's an idea. Why not like do a couple problems from the homework?
I asked first.
Run to the bathroom.
I asked first.
Alright. Does it matter who asked first?
Yes.
Do the practice quiz. And if you can't do it, you see me in the morning or something.
This is the one that we turned into.
Oh, I'm so excited for tomorrow. Just because my outfit's gonna be so nice. Oh my gosh, like it literally took me so long
Wait,
to
where
like.
do you get?
I got the skirt from American Apparel, so it's kind of
Oh,
expensive. Yeah.
Mr. Park,
Yes.
I have the first part.
It's like
The second part's downstairs.
But then it's like.
Well, then go get it.
Not like the business material, but like the nice material. Like
Well,
the
we got
soft
10, 11 minutes.
But I think it's cotton.
Where downstairs?
Wash it.
At the table.
Like in the.
Because it'll shrink.
Yeah.
Senior bench?
What if you
No.
wash it and you don't put it in the dryer?
The table. What table is this?
Anyway, and it's
What
like
are we
a
talking
like a
about
gray
here?
skirt, and then the top is like white, and it's like a cotton like turtleneck material. Oh, it looks so nice. So I got that from Forever 21, and it's like new, so it was like $7. And like you know how new stuff is like really really cheap, so yeah, you should go now. And then like yeah, that's pretty much
Oh.
it. And then I feel really bad because I literally spent like all day looking for an outfit, and I didn't
Yesterday?
I didn't do anything. Like I have to memorize like.
Yeah, I didn't start with it. We'll just give them whatever.
Which one?
Cause we had to decide like which part of the, you know how there's like all these things on the rubric? We had to decide like who's gonna do what.
You guys haven't made your presentation.
No, we made it, we just don't know who's gonna say which part.
Don't think the person who made it would say it? Cause they researched it?
No, we all kinda just did everything, like, I don't know.
That's weird.
No.
Oh, today got mochi chicken.
Really?
Yeah, I didn't know that.
How did, oh, I'm sorry, can I look at this?
No, it was, I didn't train it. She got cut against it.
She's a senior. I didn't know you could get cut as a senior, to be
Are
honest.
you just copying the same thing?
Yeah, it's just to practice.
Does it actually help?
Wait.
No.
Wait, it was Kristen.
Okay, what, how do you think you did on the chemistry test and your product?
Oh. I think I was okay. It was as hard as I thought it was gonna be, but I got like a B or something. How about you? There's okay, there's so many problems that I really wasn't sure about. Wasn't that bad? The one with like the negative 10 degrees Celsius.
Yeah.
Do you remember that one? I did not have that at all.
First of all, some multiple choice questions, I just like, was like, what?
Are you serious? That was like a huge part.
They're like some, like three that I like
Which
really
one?
were not, I
It's
don't
only
know,
fun if
specific,
you're
but like one of like the first one.
It's only fun if you're smart.
I was just like, what the hell is that?
Yeah, me too. You didn't get that one.
So
I
I
just guessed,
think,
I
I remember
guessed.
it's like 23.9, but it's like 23.6, and I was like,
Wait,
okay.
years ago?
Yeah, I
9
totally
and
guessed.
6, and I was like,
Well, I
I'm
think
gonna
that
put
was
my
like
hyper, so
back
it's
then.
gonna go with a bigger number.
Yeah.
Anyways.
I think I got a B. That's my guess.
There's like another one I can understand. And then, you got to the second page. Like, I
Then how do you get this answer?
I was so
That's
done.
not the right
I
answer.
didn't even
No,
look
that's
at
not-
any
that's
of the
actually
problems.
one.
I was like,
Yeah,
it's
remember?
the last,
You did it on the board.
the last one, like I kinda
The
did.
second to
How
last
can be,
one.
the answer gotta be less than, look,
All.
it's
Yes.
from here to
Mm,
here
you're gonna
is
get like
50
1 point.
feet, gotta be smaller than 50.
It was so.
I found that.
And then the essay, like, I have no idea what to do.
Did you copy it down?
You didn't talk about it.
No. I went to go get this
I
one.
didn't know what it was.
Really?
Yeah. I mean, I know what it is because like everyone talks about it, but like
We
scientifically,
didn't know how to.
like I didn't really know
Hockey got
what
in
it
second
I
was.
wrote
team.
so much. it's probably
And she
too
played
tired to
0.5
read.
seconds of the season.
I filled up the whole entire space. I wrote super tight.
Yes. And I got on second team.
I just talked about
Apparently,
like,
Brooke Rollins is better than me.
I don't know actually. It's writing so easy for me. I can like I can just keep going.
Okay, whatever. True is
Yeah, that's
whatever. She's a better.
Anyways, and now,
But
no, there's no. Oh my gosh, I
how?
wrote a script
She
for
scored
myself,
1 goal against St. Francis.
and this is like my whole script that I have to say.
Oh my gosh,
And I have
that's
to like
long.
memorize it by tomorrow. And I know
That's
nothing.
nice.
She's okay.
Like, it's so hard to research Sao Paulo.
Who's really out? You got this.
Spanish and
Oh,
like, yeah.
I see.
Or like Portuguese
Oh
or I don't
my
really know.
god, you speak Chinese.
What?
A lot of the information I had
Mr.
was in
Bowman,
Chinese, and I was like, okay,
Huh?
I don't know what's
my
my
locker.
Whatever.
Yeah.
I'm so frustrated.
Yeah.
Fuck, are you still filming?
Messed up. It was rigged. This whole thing is rigged. Who is Jamie?
I can tell you how to pronounce things.
Oh, I just
Do you
got
have
it.
Beijing?
Yeah.
Okay, Alicia is so excited.
The government position for 5 years.
Not even half a minute. The game started and she sat down.
Who's on?
Because she
Oh,
just wanted to start her senior night game.
what?
She was gonna be the whole season. Like, we put her on for like
Wait, what is his Instagram? He didn't send it to me.
So like she
not work.
Cause there's no work.
Try again. She's second team.
I just told me what
What
it
was
is.
that?
Did I just get
John,
my
I thought you said you'd be behind.
No.
But I'm gonna be ahead tonight. Mm.
Oh yeah, just go to send.
Oh my god.
Oh, because I turned my VPN on.
It's like you weren't really that good enough, but we noticed you. It was Sacred Heart. No, St. Francis.
Oh yeah, are you guys gonna wreck this season?
Okay.
Thanks.
Okay.
C's.
I don't even know any of these people. I only know Shauna and she's pretty good. I know this
A little off.
girl.
What does that mean?
Tara. Second team boy.
Wait, how long is
She's
that?
the first team I would know for sure.
Lamb boy.
She just kicks it super hard. The goalie is not good enough.
At most.
Okay.
Like you know, like the peacock bird is like really ugly.
How long is your guys?
Oh no, this is Carrie.
5 minutes.
I think he's saying that she's ugly. Basically.
Yeah, no,
You.
that's, yeah, exactly.
They lie.
Kylie Kim.
No, her name is Carrie. They
What
just-
is LOL?
What? I don't even know. What is
Floss.
floss? With a zero.
I
Is this something like it?
Whatever, Kylie's good. Or like goals this season.
I think Zach's good. No, it's gonna.
But I mean, honestly, Brooke is.
It's her last day.
I really want to follow my dogs.
You should just do it. They'll probably let you.
No.
But I was reading, like, I found it because I was reading the comments of
And
the
what the heck?
picture, and then someone was like, oh, it's for everything.
What the heck?
Someone else was like, he doesn't tag, and then someone else was like, well, the secret's out now, or something like that.
Yeah.
We should make her
I made the second team for state.
be Ariel.
And then, like, I
Ariel.
Yeah.
60 Ariel.
That's how much I want to be done.
Gross.
I think it's like, I think it 360. 360.
Probably just red,
Oh my god. Oh my god.
Wait, can we? I'm like
I do sometimes.
pretty serious about this. Sees the Ariel. Sees the
No, it's
Jeez.
Chance the Rapper.
no, he is. He is.
and everything. My beauty. So great.
Yeah.
Me.
For breakfast, no, no.
I need to show you his
It
dad.
makes it look like a different like the blushing glow with the hands.
They show how much gold he scored.
Okay, okay.
Oh gosh, she has had on.
Are you gonna follow him?
I don't know. I'm too scared.
What will you do if I do?
No way.
I honestly don't even care what he thinks.
I can't take it seriously.
Just make sure sees the It's like broccoli.